Okay, this is a review for Chapter 8, and this is about logs. A lot of different things about logs. And of course, if you have an exponential, you pretty much have a log that's waiting to be born. If you have that, try to remember how to write that as a log. Try that one right now. I'm going to pause. You rewrite that as a log. Okay, this would be the number one thing, is being able to rewrite back and forth. So this one is log base, and you look what base you had, 5, and then you got to jump to the other side of 8, jump back, equals x. And why is that any better? Because that has a base of 5, but you can very quickly rewrite it to be put into a calculator. Everybody try to rewrite that quick. Do you remember how to put that in a calculator? Don't use the calculator, but do you remember how you would? Because that means you changed it to base 10. And that would be log 8 over log 5. What base does that have? That is a base of 10. Okay. And that means you changed it to base 10 by doing that. All right, what if you wanted it to be base 3? I know this is hard to understand. I've explained it before. You can pick any base at that moment. You can pick base 3. And now I just made, if the base gets smaller, the answer gets bigger. And so I just made both top and the bottom a little bit bigger and proportionally bigger. And so that's going to be the exact same answer as if I had log base 32. It's going to be the same answer because you're just scaling both of them up. All right, so it can be any base you want. All right, next thing. Let's say that you had a more complicated one that was a log. It's not that complicated, but it starts as a log. Rewrite it as an exponential. Remember, when you get stuck in a tough log question, think, can I rewrite this into the other form, whether it be from a log to an exponential or the other way around? This one would be 3 to the 5th equals x. Raise your hand if you had that one right. Why is that better? Because x is alone. It's solved for x. It's done. All right. So some patterns. Do you remember when this number right here is a 3, good things happen because the base of the log and the base, with it has a little power of 1 there, have the same base. I like to think of this as having the same base, and the answer is already there. It's 1. Do you remember if it's like this? That's the base of this exponential, and this is the base of the log. If the bases are the same, good things happen. What's the answer? 5. All right. Now, let's say that we had won the argument. Won the argument, you get nothing. Another way to say it is, if there's no variable, you can say equals x, and then you can rewrite it. And you'd say 4 to the x equals 1, and then you'd think it through and go, 4 to the what equals 1? Oh, yeah, x has to be 0. All right. Next one. What if this is 4 and this is the 2 to the 2, we'll just say 2 squared, and then make that the 5th root. Okay, figure out what that one is. You want to force them to have the same base, and then your life will be a lot easier. Log base 4 of, isn't that really the 4th root of 4? This 2 squared is 4, right? And isn't log base 4 of 4 to the 1/5 the same thing? Remember, the roots go on the bottom of your little fraction power. Okay, so what's the answer to that one? 1/5. All right, some other rules about logs. If I have log base 2 of x plus log base 2 of 10 is equal to, let's say, 5. Do you get that you will never solve this unless you get those 2 logs condensed? Remember condensing? All right, so try condensing these 2 logs. You have to be good at these. One of the reasons it's definitely prominent on the final is logs are a big part of calc. And you're all going on to some flavor of calculus for next year. All right, so you should have condensed that down to log base 2 of 10x. Why? Because add turns into multiply when you are condensing logs. equals 5. Now there's a couple ways you could solve it. One way would be, do you remember me telling you that you could always multiply by 1 creatively? Why did I just do that? Because now I have logs on both sides. That 5 can come up and be a power on this. And then the logs can be removed. And 10x equals 2 to the 5th. And then you just divide by 10. I'll back up. Started there. Put in a log base 2 of 2. Why? Because that's equal to 1, and I can do that. And now I have log base 2 on both sides, so that'll get rid of the logs. Another option was, if I got stuck right here, Mr. Server always said that when you get stuck, you try rewriting. Watch. 2 to the 5th equals 10x. I know, that's much easier. But it is important to know that you can, if you need to, put a log in on both sides. It's especially handy in something like this. Log base 3 of x plus 7 equals log base 3 of 12. Do you get that little 7 sitting right there? It'd be really handy if it had a log base 3 on it. 12-minute warning here. We're going to go right up to the end of the hour. So this I could multiply by log base 3 of 3. And that way, this 7, once it goes up here, this can be condensed down into log base 3 of 7 to the, no, 3 to the 7th. Sorry, the 7 is going up as the power. And what I'm doing is getting that number right there. 3 to the 7th times x equals log base 3 of 12. And then that has to equal that, and it's easy to solve from there. All right, so I just wanted to remind you of this couple strategies. Condensing, got to be able to condense. And if you have a constant like that 7 was in this problem, you can multiply it by log base 3 of 3, or pick any base you want. Just make sure you're multiplying it by, effectively, 1. All right, so logs on both sides is handy, because then they can be removed. Oh, do you remember U substitutions? There's a problem that's all primed for a U substitution. Please try a U substitution here and see if you remember how to use those. Okay, so you should have said let U equal log base 3 of x. And therefore that's U squared minus 2U plus 3 equals 0. It's just begging you to factor it, because if you can factor, you should. U plus 1, U minus 3, and then this is U equals -1, and this is U equals 3. And if you are done and you only have U's in your answer, you did something wrong. So you should replace the U again with what? Log base 3 of x. Uh-oh, what do you mean? Oh, I didn't factor it right? Okay, hold on. All right, sorry about that. U minus 3. You mean it doesn't factor at all? Outside, inside. Oh, this would need to be a -3 to have it be factorable. Okay, sorry about that. I screwed up the, this should have been a -3 right here. Oops. Okay. And then it'll be factorable, and then U equals 3, and U equals -1. But to remember, don't stop there. You've got to finish. U is log base 3 of x. So you go log base 3 of x equals 3, and log base 3 of x equals -1. And some of you are probably going, oh, -1, there's a negative in it, so it's wrong, it's undefined, or it's impossible. No. You can't have negatives here or here, But you can have a negative at the end. That's an okay thing. All right, so I'm going to rewrite this. This one is 3 to the third is equal to x, and that's a really big number. 3 times 3 is 9 times 3 is 27. And, oh, did I do that wrong? Why is all of them? Oh, okay, well, okay, fine. 27 is not very big, apparently. So anyway, 3 to the negative 1 equals x. 3 to the negative 1, pausing. Okay, so 3 to the negative 1, just a quick reminder, that's 1/3. All right, some other things to note about logs. If I said, what's the domain of this? Do you remember that x can't be some things? The base is not allowed to be negative, and the base is also not allowed to be 0, and the base is one more thing, can't be what? 1. So if I was going to write the domain for this statement, x would have to be on a number line here between, well, it can't be 0, and it can't be negative, so don't shade that. Here's 0, and it's important. And here's 1, and it's important. And it can be between 0 and 1, and it can be bigger than 1. But it can't be 0, and it can't be negative. So there would be my domain for the base. How about this number? This number has to just simply be bigger than 0. Okay, you can't have anything 0 or smaller. Same thing as it has to be bigger than 0. Okay, this has no rules, though. Your exponent. Why do I call it the exponent? Because if I rewrite it, watch how the 10 becomes an exponent. The exponent position there doesn't have any rules about being positive or negative. Okay, one more thing. If you get word problems that have logs in them, they sometimes are Halflife questions. Let's say that you have a Halflife and that you have to write the equation for it. They often give you like a starter like this. Times e to the kt. Does that ring a bell? All right, so I'm going to give you a typical Halflife scenario. Let's say that we have 2 grams present of toronium, Tennessee, and it has a half-life of 21 days. Set up the equation to find K, and then rewrite the equation so that it's got K in it and it leaves T in it. So basically what they'd say is write an equation that you could use to solve for any time. And it'll look something like this. Well, its starting amount was 2 grams. E to the kt, I don't know K, but I do know T, the time was 21. And there's one more thing. I know the Y. The result after 21 days is you get half of 2, which is 1. Raise your hand if you set that up right. Good. Then you solve for K, which is really easy if you know logs. I'm going to start by dividing by 2, and then I'm going to rewrite it as a log. Log base E, yes, you could have said ln, of 1/2 is equal to 21K, and then I'm dividing that by 21. And there, yay, I've got my K. Log base E of 1/2 equals 21. And it was right here. Log base E of 1/2 equals 21. It was right there. But then I canceled the 21. I got a little too far ahead of you there. Okay, so I got my K now. So now I could rewrite the equation. And you put the starting amount, which was 2, and you put E, which is E, and you put in the K, which is this thing. Log base E of 1/2 over 21. And then you say T. Why is this equation good? Because all it needs is any time, and all the rest of this is not variables, it's numbers. Even that's a number. It's 2.718. So you can stick in a time and get your answer. That is a typical Half-Life question. And sometimes they have you simplify things like 5 to the power of log. Let's actually go with 10. And then let's make this 1/10 to the power of 10 log base. Doesn't say what base, so you should know what that means. Of log base 3 of 9. There's a good complicated one. Simplify that one down. And this is the last one that we're going to talk about for logs. We had several strategies. We used substitution. We've, not on this problem, but we've talked about patterns for logs. We've talked about putting in logs on both sides. We've talked about taking out logs on both sides. We've talked about taking constant and making them into one. We've talked about condensing logs. There's a lot of different strategies you have to know to be good at logs. All right, one little step at a time. Remember, when you have nested parentheses, basically you go to the furthest ones inside, you get that right there is 2. All right, then do you get that this has a base of 10 right there, and therefore that whole blue square simplifies down to what? 2. So then it's really 1/10 to the second, which you should simplify. It's 1 squared, which is 1, over 10 squared is 100, is 1/100th, or 0.01. All right, so there's one other that I think I should show you since I have a little bit of time. I said it was the last one. Apparently I lied. Sorry, I just thought, I'm trying to help you here. The animals in a game park kind of problem, and they give you an equation. The number of animals in the game park is, let's say, 4 times e to the 0.6t. What did they just tell you by giving you that equation? Starting amount, which is what? 4. Okay. And it doesn't say a half-life. Okay. It tells you that after t number of years, that's going to be how many animals there are. Then they might ask you, either they'll tell you how many years it's going to be, or they're going to ask you like how many leopards they're going to be. Like, for instance, when will there be only 1 leopard left? Well, then you'd put a 1 right here and you'd solve. Or if they say, after 3 years, how many leopards will there be? Well, then you'd put a 3 here and you would solve. And once again, to actually solve it, you've got to get this clump alone. So you'd always divide by 4 first, and then you'd do a rewrite as a log. So that's got to be it, because it's just about time. All right, that's the last chapter. Good luck on the final. I guess technically the last chapter is chapter 9. We've already reviewed for that so much that I've made 2 other videos for that. So